So this question was a knec examination question for the student doing diploma in civil engineering in the June-July 2016 exam series. So the question says, design a timber floor joist for a suspended floor given the following information. So this is the information you have been given. Spacing is 500, effective span is 3.5 meters, dead load, imposed load, and the grade stresses. So I've already started here. So what I've done here, I've just sum up the dead and imposed loads. I got 2.25, then multiplied it by the spacing. I've just changed this into meters to get 0.5. Then I got my load here. This is the factored load, is here. Then I use that one to calculate the maximum bending. After that, I use this formula that says Z is equals to maximum bending all over the grade stress. So I find here, and then we have this one. So in this question, we have not been given the depth to breadth ratio. So we have to assume it is 3. So let's continue. So what we'll just do, we will equate this one to this. So Z will just replace D in the place of, we'll just substitute this one, just place 3D into here. So it will be so 3 squared is 9. B squared times B is B cubed divided by 6. 3 here, 3 here, 2. So we get 3 over 2 B cubed. So this one, we will equate it to this. We equate it to this one. It is the Z value. So we'll say so after equating this, we'll just we want to remain with B cubed on this side. So we will multiply it by 2, then divide it by 3. So let's get the cube root of B cubed, then cube root of our answer here. So B is equals to, after punching this into the calculator, so we get our B to be 60.07 millimeters. So that means that our D is equals to this one times 3, which will give us a 180.20. So we will not use these values. We'll just go and obtain our values from the table of timber design. So the value we got, we'll say use this is the what we'll use. This is what we'll use. Now we have to check for if our 75 by 225 millimeters joist is adequate. So let's start by checking for bending. So our permissible bending stress, the formula is ZF. So the formula for getting Z, we know is BD squared over 6. And then now we multiplied it by the grade stress, this one. Parallel to grain, we have been given, it is here. So bending stress parallel to grain is 5.3 newtons per millimeters. And our BD will use these two values. So our F value will multiply it by the K factors. We have been given here K factors. We have K, the load sharing factor 1.0, then we have the 1.1, and then we'll calculate calculate the K7. So here we have been given 1.0, 1.1. So K7, we can get it. Let me calculate the K7 here. So punching this into the calculator, I will get K7 is 1. So my K7 is 1.03. I'll put it here. So in using the calculator, get this is 3. So punching this in, all this into the calculator, I get this permissible bending stress is 3.80. So we will compare this to the maximum bending that we had already calculated. So maximum bending is here. So in order for the beam to be adequate for bending, the maximum bending should not exceed the permissible bending. So as you can see, 1.723 is less than 3.80. So our joist is okay for bending. So now we'll check for shear. So checking for shear in our beam. So to check for shear, we will first calculate the shear force. So this is the shear force. This is the formula WL/2. That is the formula for getting the shear force. Now we get the actual shear force. So as you can see, I'm now using 75 times 225 for the BD, and then this FV, this the shear force here. I've converted it into newtons. So we punch it into the calculator, we get now let's find the permissible shear. So to find the permissible shear force or the shear stress, we'll use our grade stress from that were previously given. Shear parallel to grain, which was 0.67 times the K factors. So comparing these two, the actual shear force should not exceed the permissible shear force. So 0.175 is less than 0.737. So our joist is okay for shear. So the joist is okay for shear. Now let's check bearing in the beam. So permissible bearing, so the permissible bearing stress, we take the grade stress times the K factors. So we were given here the compression parallel to grain was 2.2, so you take this 2.2 times K factors, that will be our permissible bearing. So now let's get the actual share the actual bearing so that we can compare with this. So our shear force was 1.97. So the bearing length we have not been given in the question, so again we have to assume, let's assume it is 150 millimeters. So multiply it by 150. This 75 is our breadth that we had calculated earlier. The breadth we got here, this breadth of 75 millimeters. So that is B times the bearing length. Bearing length we have assumed 150. So we have find that the actual bearing is less than the permissible. The permissible was 2.42. It is greater than the actual, which is 0.175. So that means that our joist will not fail in bearing. It is okay for bearing. Let's check for deflection. So we were told here that allowable deflection is equals to 0.003 times span. So that's what I've done here for permissible deflection. So 0.003 times span. I've converted this 3.5 into millimeters. That's here. So that one, putting it into the calculator, I get 10.5. So this is the formula that we will use to calculate the actual deflection. So 5 times the load was 1.125. So it is in kilonewtons per meters. We change this into into newtons by multiplying it by 1,000. Then this one into millimeters, we divide it by 1,000, so it will remain like this. It will remain like this. And then our length is 3,500 raised to power 4. The Young modulus we were given in the question, it was 8,800. The inertia we will calculate, we don't have it, so let's use 75 times 225 cubed divided by 12. So punch it all into the calculator, we get the actual deflection is equals to, let me show you how we put it into the calculator. So we get our actual deflection to be 3.5. So our joist will not fail in deflection, because the actual deflection that will occur in the 75 by 225 millimeters joist, the actual deflection will be 3.5, but the permissible deflection is 10.5. So we are okay for deflection. That is the last thing we have to check. So see you in the next video.